For this example, we would like to evaluate the integral of 1 over x ln of x. Now, a key observation to make here once we get started is that whenever we see something like this where we have maybe a more complicated looking function, like in this case, say the natural log of x, which is appearing inside another function here in the denominator, but it could be inside something like a cosine, a square root, a sine, exponential. What we want to do is immediately think, do we see its derivative appear anywhere else outside of that function? And in this case, with a little bit of reorganization, we see that it does. We have this 1 over x, which appears. So just rewriting this slightly, we can always break up multiplication and write this as 1 over the natural log of x multiplied by 1 over x dx. And now it's much more clear that what we would like to do is the substitution u equals natural log x, so that du becomes 1 over x dx. So our integral that starts off solely in terms of u's, the natural log x in the denominator can be a u, and this 1 over x dx portion is simply going to become du. So converting from all x's into all u's, we would have the antiderivative of 1 over u du. And the key observation again is to make that we start off with what's a potentially difficult looking integral. We apply the substitution to it, get it solely in terms of the variable u, and this resulting integral is much simpler for us to evaluate. So natural log absolute value u plus c. And whenever we're evaluating an indefinite integral with a substitution, our last step is to come back and resubstitute. So putting that u in terms of x, this becomes the natural log of the absolute value of natural log x plus c.